still let me start from a little back, because if you have a very good idea on differentiation, it will help you a lot to understand the integration part.
Integration.
Okay, so so uh, let me start with function concept. Function is also important, and let me just give you one example here. Say I was talking about uh, sweetness, okay, of tea in the last class, that is yesterday's class. uh, is depended uh, on how much sugar we add, okay, or how much sugar is added. So this is one sentence, and this sentence is an example function, isn't it? Is that clear? The idea is clear to everyone?
Yes, sir.
So,
Why it should be called a function? Because sweetness is one thing here, and how much sugar, that is another thing, that is another
Yes, sir.
matter. Okay,
Yes,
Yes,
sir.
sir. It is
Dependent and
dependent
independent
on
variable.
sugar.
right, right. So the function, actually the relationship between two items, or you can say two types of variables. So one type of variable is dependent variable here, and normally we call this y, okay, and the other type of variable in this example is uh, sugar amount, that is the independent variable, and we call this uh, independent variable, we call this x. Okay, this is the normal symbols we use, but it doesn't mean that every time independent variable will be x. Okay, so in this case we can say the function is actually y equal to fx. Okay, so in this example we can also do differentiation. So the result will be d dx of y, that is first derivative. So what you will say about this first derivative for this example? Can anyone just speak out? What can you call the first derivative in this example?
Sir, it is the rate of change in y with respect to x.
Okay, that is the definition. That is the definition. But I want you to tell the same thing in the context of example given. So for this
Sir,
example, what it should say?
Rate of change of sweetness
with
Yes,
respect
in the
to
with respect to the amount of sugar.
sugar. Yes.
yes, correct. So there is a condition also there. Uh, the rate of change in sweetness with respect to change of amount of sugar. The condition is the change of amount of sugar should be very, very small, should be however small, right? So that is the condition. So this is called d dx of y. And if you find maxima minima here, so what will happen? If I calculate maxima minima for this function, then what will happen actually? What will come?
Sir, maximum sweetness and minimum sweetness.
Correct. So is it clear to everyone?
yes, sir.
Do you understand this thing? Everyone. I
Yes, sir.
do not want that only the good students will understand this. No, this is now the uh, mandatory level of understanding for everyone. Okay. So at the beginning of differentiation, maybe, okay, I was thinking, okay, fine, the good students will understand better or more things, and some other students will understand gradually, time to time. But now it is time that every one of you in this class will understand this thing. So maxima minima is actually all about the function, that means the dependent variable, that means in this case the sweetness. So in one example you can find only minima, may be possible, so that will be maximum sweetness of tea. If you find only minima, the same thing, minimum sweetness of tea. If you find many answers, okay, say 2 maxima, 3 minima possible, but all those things, everything, 2 maxima, 2 minima, 3 minima, everything will be about the function, that means the sweetness of tea. And this will have a situation, that is for how much amount of sugar the sweetness will be maximum, that is possible. So the x can be a particular value. Say you can say, okay, x equals to 1.5 tablespoon of uh, sugar, maybe possible. So if you think, no, this is not maximum, so maybe, okay, I will put 3.7 tablespoon of sugar. Yes, possible. So there are different x value may be considered in this example. For different x value, maximum will be sweetness, minimum will be sweetness. So maxima minima is not about your independent variable. Be careful. Maxima minima is not the x value. This is always the y value. That is dependent variable. So it should be the clear concept for everyone in my class. Maybe you are not the very good student, but everyone should have the clear concept on this. If you have the clear concept of this, then you can enter the world of integration, and it will be better to understand. Then every time you will just learn the things quickly. And in this course we will not do the things very critically. That means we will not go into that deep level, because this is the basic level course and it is designed for everyone, for all the programs. So it will not be critical to understand and to solve the problems. But for the students who will be doing some engineering courses, they will have more calculus courses, and this understanding will help them a lot. Okay, because in other level calculus courses, maybe you will be doing some more complicated things. But if you do not understand the real essence or real meaning of differentiation, integration, in that case it is meaningless. I mean, you will be doing just some problems, and formula, but you will not understand what you are doing actually. Okay. So in this course, even this is a basic level course, but in this course also we will do some application of integration problems. So if you want to understand the application of integration problems, you need to understand the thing clearly. Okay, theoretically it should be very clear. So let me give you another example. Uh, the common example, say the demand is a function of unit price. Okay, so this is the function example from our real life situation, and you can now do the same way ddx of y. In this case, what will be your y and what will be your x?
Demand is Y and unit price is X.
Good. So demand is the dependent variable. It is called y normally, and unit price is the independent variable, and we normally call it x. So what will be the ddx of y in this case? What you can say?
Rate of change in demand with respect
Yes.
unit price.
Correct. So is that okay to everyone?
Yes, sir.
Yes, sir.
Okay. So if you change it like uh, cost, okay, cost is a function of uh, uh, say number of units, number of units produced. That is, you are producing some thing in your factory, and number of uh, items will be the number of units produced, and cost is the total cost. That is how much you need to spend to produce this thing. So you will say, for this example, what you will say about ddx of y? Jamak is present. Mohammed Jamak. Jamak, are you present here in the class?
Yes, sir.
So I will ask Jamak to answer this question. Can you answer this question? The function is total cost is a function of number of units produced. In that case, total cost is dependent variable, that is y, and number of units produced, it is the independent variable, that is x. And if you find ddx of y, what you will understand by this? Tell me what is the meaning of ddx of y in this case.
Sir, it will show you the change of the
My
show you.
question, yeah, my question is clear, right?
Yes, sir.
So yes, try to give me the answer. Do not worry if it is wrong. That is all right. I will explain it again. Okay. So tell me the answer. What you will understand by ddx of y in this case?
So, sir, the should I tell you the two concepts?
Yes. You will tell me the concept of differentiation here, that is ddx of y, as we were talking about the rate of change in y with respect to change in x. Just like that, you explain this in this example function.
Sir, I don't understand.
You do not understand. Okay. So, Saim Ahmed, can you tell me the answer? Saim Ahmed? No. Okay. Safin Ahmed, can you tell me the answer?
No, sir.
No? Okay. Okay. Then let me ask another person. Say, who is Robin Iqbal? Allama Iqbal is Robin Iqbal? Robin Iqbal, are you Allama Iqbal?
Sir, he is Allama Iqbal, but I think he's having some network issue. network problem.
Okay, so he cannot answer. Okay, so tell me, Navid Noroz, what is the answer for
Yes,
this
sir.
question? Yes.
Hmm. Sir, so may I see the... Yes, sir. So here, the total cost is a function of, sir, unit price, right? So
No, no, no.
the...
No, total cost is not unit price. Okay, so let me write it down
Oh,
again.
demand is a function of unit price, right?
Yes, yes.
Oh, okay,
And
sir.
total cost is depended on number of
Units
units
produced.
So
produced.
produced. Okay.
Yes, yes. This is the situation. Yes.
So,
So what you will tell for this?
sir, for the total cost.
Hmm.
Yes, sir. So, dy dx, if we tell it like that, that means if total cost is y, then
Yes.
the total, depending on the like on the unit produced, the change or in total cost will happen.
Yes. So what is the meaning of ddx of y? You
Oh, the...
actually explained the function. Yes.
Yes,
So
sir.
you tell me what is the meaning of ddx of y?
ddx of y is the change in total cost.
Rate of change.
The rate of change, yes, sir. The rate of
Okay.
change in total cost.
And you
Uh,
have to complete the sentence.
yes, sir.
Yes.
The rate is on the rate of change
Change
in total
with
cost. Yeah,
respect to.
with respect to number of unit produced, where
With
the
number of units.
unit produced is however small.
Okay, so that is also all right, no problem. You have answered correctly, but it should be much more clear and confident. So, Jamak,
Uh,
is that clear? Jamak, is that clear? Or anyone has question? Yes, please.
no, sir, no question. It will be the rate of change in total cost with respect to the number of units.
Okay. Is that clear, Jamak?
Yes, sir.
So now you know what it is, right? So you tell
Yes,
me
sir.
why I am asking you. Why I am asking you?
Just to have a clear idea about it.
This is true, but there is another reason. There is another reason because this thing is the matter of economics. This thing is the matter of economics, and in economic term, it is called marginal cost. This is called marginal cost. So by this time, I'm sure you already know what is marginal cost. So you tell me what is marginal cost, what you have learned in economics. Can you tell me what is marginal cost?
Sir, extra goods that been produced is called marginal.
Yeah, yeah. So tell me again, a little slowly. Yes,
Sir,
tell me
like
again.
actual, like marginal cost, like extra cost that which is like willingly produced or actual produced.
Yes. So that is the thing. So you are saying extra cost. Everyone is listening. So
Yes.
you are saying extra cost that is needed to produce some more items. So that is the single item for one single unit. Actually, whenever you see marginal, this word, you will understand this is the rate of change in blah, 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 blah. You understand? So that may be marginal cost, that may be marginal profit, that may be marginal this, marginal that. There are many words in economics and business like that. It is not only the economics matter, it is also BBA, MBA matter. So whenever you see this, all these are actually the derivative. All these are actually the first derivative. So this is the example. It should be very clear to everyone now. Okay, can I erase this now?
Yes, sir.
Yes, sir.
Okay, good. So let me just move on with the same idea, and this time I'm writing another thing. Say it is distance is a function of time. So
Yes, sir.
for a moving particle, okay, so there is a moving object or moving particle, so it is being moved one place to another, it is just going, okay, and then this is the situation. So this is the function example. Here distance is the dependent variable, we think about y, and time is the independent variable, we can think of x for that. And again, if you do the ddx of y, so you will say this is actually the rate of change in distance, with respect to change in time, right? Rate of change in distance, distance with respect to change in time, right? So there is a condition here, the uh, I mean change in time, okay, change in time is however small, yeah. So there is a condition, but main idea is the first part. So this is the main point, and ddx of y understanding is this, right? So the person who knows science, who knows physics, you can say that this is called velocity, right? This item is called velocity. So you can easily say, or you can easily understand, okay, this is velocity, fine, no problem. So if you have one equation with distance and time, if you do the differentiation, the velocity will come, right? So ddx of y in this case is the rate of change in distance with respect to change in time. This is the understanding in calculus. If you know the name, velocity is the name, then good. If you do not know the name, say you are not from science group and you do not know physics and you do not know the name velocity, that is also all right. No problem with calculus here. Is that clear?
Yes,
Up
sir.
to up to this, it is clear, right? Anyone does not have any question, right? Okay, now tell me what will happen if I do second derivative here, that is d2y dx2. If I do this, then what you will say for this
Acceleration
thing?
will come.
So rate
Yeah,
of change in
so
velocity with respect to time.
correct. So that answer I want actually. Acceleration is okay because you know the science, because you know physics, so you know the name. Okay. So that is good thing, no problem. But in this differentiation, what I want, you will understand that this is actually the rate of change in velocity. You will understand that this is the rate of change in velocity, okay, with respect to change in time. Is that clear or not? Just try to understand this thing. If it is
Yes, sir.
clear, then fine. Then I am happy. Okay, I want you to understand this thing. Is that clear?
Yes, sir.
Because
Yes,
yes,
sir.
so
It's clear.
because you are doing, again you are doing differentiation for velocity. You are doing differentiation, that means ddx of velocity. Actually you are doing this, and velocity was the first derivative. So you are doing differentiation for velocity, that means actually you are doing second derivation, and this is the answer. And if you know the name, fine, this name is acceleration.
Acceleration.
Clear? So let me write down another thing here. So, or let me just erase this thing.
Sir,
Yes.
if we do the like the differentiation once more, then what will be the name?
Okay. So if you do the differentiation once more, that means
The
ddx,
rate of change
ddx,
in acceleration.
exactly. So ddx of acceleration, and ddx of acceleration means from the original one, that is the starting one, it is actually third derivative. Okay, from
Yes, sir.
the y equal to fx, from the original distance time relationship, it is called the third derivative, but it doesn't have any name. Okay, anyone knows the name for this? Do you have a name in physics for this?
No, sir.
No,
So
sir.
so
I
that is
don't
all
know.
right, but differentiation is possible, right? 4 time, 5 time, 6 time, that is possible. Differentiation possible. Understanding is same every time, but there is no name for this. So this is the situation. Is that okay? Clear? Now you
Yes,
can think about
sir.
integration. Now you can think of integration. Actually, integration is the opposite process. Okay, just integration is just the opposite thing. Okay, integration is uh, reverse. I call this reverse process. Okay, of differentiation. So exactly it is the opposite thing of differentiation. That means if you know the differentiation formula clearly, then integration formula will be easy to you. Okay, so in this example, what we have done right now, the first thing was distance, and then we have got velocity, and then we have got acceleration, right? So in this example situation, if you think about differentiation and integration, you will say you do the differentiation of distance, the result will be velocity. That is ddx of distance will give you velocity. If you do the differentiation of velocity, that will give you the answer acceleration. And in the opposite way, if you do the integration of acceleration, it will be, the result will be velocity. Okay, it is the integration. So if we do integration, that means we are doing opposite thing of differentiation. So from acceleration you can come back to velocity, and from velocity you can come back to distance. This is the understanding of integration. Now you understand what I have said.
Yes, sir.
So any question so far?
No, sir.
So, sir, what will you call the rate of change in acceleration
No, 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 no.
like that?
That we will not call this in that way. But the understanding is this. The sentence is not like that. Okay,
Okay, sir.
but the understanding is this.
Yes.
Okay, so let me show you a few slides. Okay, now, and I will share the slides with you later. No problem. But if you want, you can just copy or write, no problem. So these are the slides here. Can you see my slide? The first slide is integration, and 3 points are written here. You can copy or you can write it on your khata. It's up to you. I will share the slides later, okay? And maybe right now you will not understand all the words written here, but I will explain and I will do some problems, then you will understand. Just read it, okay? Read the things. So can I move to the next slide?
Yes, sir.
Yes, sir.
Okay, so let me show
Yes, sir.
you the next slide. This slide is the difference between or comparison between integration and differentiation. So I have put 3 points here. You will understand all the points time to time. Just read now. What is integration? What is differentiation? Okay, have you read it?
Yes, sir.
Yes, sir.
So let me move to the next slide. Okay. Next slide is this. This is the same thing what we have just done, right? Now you have got the symbol for integration. Okay, Ajaruddin was asking because he is not from science group. So he was thinking, okay, what we will call the integration now. So the persons who are from science group who already know what is calculus, then you already know what is the symbol for integration. So now you check actually the things are the upper symbol is differentiation, that means d dx, you already know. So the d is differentiation and the lower portion dx is with respect to x, right? And it is actually the same thing here in lower symbol. If you think about dx, that is the same thing with respect to x. And the first symbol, which is like a long s, s means summation, okay? So summation word, uh, the first letter s is used for integration. And this is, maybe it is not like an s, but still it is coming from the summation s. So long s symbol is the integration symbol, and within bracket you will put the function, that is the problem. Okay, so I can give you any question in the exam and I can ask you integrate this thing. So you will put the integration sign in the beginning, then write the question, then after the bracket you will put dx because you are doing with respect to x. So if you do with respect to other thing, if you have the independent variable as other symbol, not x, in that case you will put that. Okay, so it may be dt, it may be dp, it may be dq. So any symbol can be used, that is the with respect to. Is that clear? So some of you are very new with this idea, so you need to know.
Yes, sir.
And if you already know, then fine. So If you do integration of acceleration, that will bring you velocity. If you do integration of distance, velocity, that will give you the result of distance. So this is the understanding. Is that clear?
Yes, sir.
Yes, sir.
Okay, so let me move to the next slide. And in this slide, I am giving you some basic integration formula. So these are the basic integration formula. You can just write it down. You can just copy all these. I will, use it in some example problems in the next class. Today, it's not possible. Just write down the formula that will help you to attend the next class. I will explain what is happening here, how the formula is used, or what will be the example problems. We will discuss and do some problems in the next class.
Okay, sir.
You just copy all this formula.
Sir, here C means constant value
Yes,
or variable like that.
yes, constant value, yes. So done.
Yes, sir.
Yes, sir.
Okay, so these are the 5 formulas here given, and if you carefully check, then you will see all the formulas are actually opposite to the differentiation formula. So I will explain how these are opposite and how can you use it in problems. So we will do some problems, then you will understand easily. So these are the basic formula, and there are other formula also. So we will not be able to learn everything in this course. Actually, there is another important message I should uh, share. That is, actually all the differentiation techniques are done. So you should now be able to differentiate any problems, all of the problems, because all the formulas are already done. But integration, it is not possible to learn all the formulas or all the techniques in this course.